All right, everyone, we're back. Now we're going to talk about the NSX T components, specifically what they're made up of, what the components do, all of that. And then immediately following this video, I'm going to get into the CLI and the GUI and give you kind of a quick tour of everything and just start to make it a little more real so we can get a little more practical now that we've got a good grasp of these basic concepts. So when we talk about NSX T, one of the core components of this solution is what's called the NSX T Manager. And the manager is, in this case, in this drawing, it's got this blue line around it. This is just an OVA, or in other words, it's just a VM essentially that's deployed as an OVA. And its purpose is twofold. One, it has this management plane component here, and it's also got a control plane component, and that all sits in within the same VM. So I want you to remember that. So one NSX T Manager, it's responsible for management and control plane. And of course, we want to be redundant. We want to make sure that we could scale up larger if we need to. So we deploy 3 of them. And that's the standard deployment, would be 3 for redundancy. Now we can lose one without any issues, but if we lose 2, then basically the network is in a position where we don't want things to move around. Now you're probably asking, why wouldn't we want things such as, like, we'll say a VM to vMotion while the managers are down? The answer is really around the purpose of the control plane function of the manager. The control plane's whole purpose in life is to say, I know about VM A, I know its MAC address, and I know what TEP or tunnel endpoint, in other words, what host it's sitting on. So that when I need to encapsulate traffic and send it to that VM, I can encapsulate it with the correct TEP address. Well, let's say the controllers are down. If I go to send traffic, I don't know where it's sitting. I don't know what host it's sitting on, and as a result, I don't know the correct TEP address. It is worth mentioning that if all 3 of these managers were down, we could still send traffic and everything would function fine. We just can't move things around because then the controller tables are not there to keep track of them. So that's just something to be aware of. I want to go kind of backwards to the management plane component. What does that mean? Well, when I say management, I mean anything from the GUI, I mean API calls, automation, maybe I'm going in here and creating a logical switch. Maybe I'm going in here and I'm logging in via the GUI and I'm creating a logical router or connecting a router, configuring NAT, or maybe I'm even configuring security rules or firewall rules. So all of that would be kind of this management plane component of it. And then when we talk about the data plane is where packets are actually flowing. So it's important to know that these managers are not in the data plane. There are no packets that will pass through the managers. That's not how the solution works. The manager is only management control plane. When we talk about the data plane, there are components that are directly in the path. So starting from left to right, as you recall, we talked how NSX has support for multiple types of workloads. So we have our ESX host right here, and on it we have the NSX VIB or VMware Installation Bundle installed. That means the host is prepped and it's basically going to participate in the NSX T data plane. We also have the same that can be true for KVM hosts or even bare metal servers. And we also have this concept of an NSX edge, which we have a whole section dedicated to the edge, but you can think of it as your on-off ramp for anything to and from the NSX T environment. Finally, we have this public cloud gateway, which is nothing more than just an NSX T edge that happens to live in AWS or Azure. So with all of these components here, they're all prepped for NSX T, they're all participating in the data plane, and as a result, they need to get their configuration, they need to kind of get their marching orders somehow. So how do they do that? Well, they're going to get that from the manager. So I'm going to come here and I'm going to say, I want to make a change, I want to set up a router or a firewall rule or IDS or whatever the case is, and the manager's responsibility is to take that management plane component of the VM and it's going to push the config to any of the affected nodes that need to know about it. And we can get very granular here. We could say, I only want to push it to these 2, depending on what we're talking about. If we're talking about creating a firewall rule, I could even say, I could limit it to wherever, we'll say, wherever the web servers are sitting, I want to push it to those hosts only. But ultimately, the configuration is coming from the managers. There is one more point which I failed to mention in the previous slide, which is that the NSX T control plane is always active, active, active for all 3 nodes. Basically, they split the load at all times. And from a management plane standpoint, it's only active, standby, standby. So one manager is active at a time from a management standpoint. If we were to lose that manager, then the other managers would pick up the load and one of them would go active and we'd be back up and running and we could log into the GUI and all of that stuff. But the control plane would be up that whole time because it is active, active, active. So just to summarize the NSX T Manager, it's not the data plane, there's no packets flowing through it, it's strictly management and control plane. It also functions as both of those components, obviously, and it's deployed in a cluster of 3 for redundancy. We can in a lab, especially in a home lab, it's totally okay to deploy one of them. In fact, I would recommend that, but you can play around if you want to, see how the clustering works. It's very simple, so we'll go through that as well. So the other thing I wanted to mention is that the managers can also be on the same subnet, but they don't have to be on the same network segment. It's perfectly fine if they're not, but there are some ports you need to make sure that are open, and they can all be found in the NSXT documentation. Finally, the last thing I'll mention, which I kind of touched on briefly, was the NSX T Manager is the entry point for GUI changes, or otherwise we're going to log into the actual web interface like we'll do in our next video, and we can make changes. But also if you're using any APIs or automation, that would be pointed at the NSX T Manager, and that's another function of the manager as well.